to be successful, we need to label the largest side the hypotenuse. Remember, the largest side is always across that 90-degree angle. Then we're going to label the other two sides A and B. We're going to add the squares of A and B and get the square root to find C. And if they give us the opposite, or not the opposite, if they give us the hypotenuse, then we're going to subtract the squares of C and A and then get the square root to find B. Then we're going to determine if a triangle is a triangle or if a triangle is a right triangle or not, by seeing if A squared plus B squared is not equal to C squared. But before we start, we're going to look at this video because for me, it just made sense. And hopefully it'll make sense to you. When we talk about squares, we're literally talking about squares. Each side creates a square. Now, if you look at my video, we have water on these two squares. Does everybody see that? Once we turn it over, check out what happens. When we combine the squares of both of those sides, it fills up the third side or the third triangle completely. So when we combine them, what operation are we using? Adding, subtracting, multiplying, or dividing? We're adding them, right? So we're adding those two squares to get that larger square. And that's what Pythagorean theorem does. The link doesn't work. Give me a second, Gabriella, and then I'll get to it again. All right, so now the opposite happens as well. So if we have the big square and we're trying to find the little square, then what we can do is fill up the middle square, and this one's filling them up both at the same time. But what if we only knew this part? Let's say the medium square. What operation would we use if we had the big square and the medium square? How can we find our smaller square? Would we add, subtract, multiply, or divide? We would subtract. So if we have the big one, to find the other little one, we're going to subtract our two sides. And if we have both of the smaller ones, we're going to do what to find the bigger one? Are we going to add, subtract, multiply, or divide? If we have the two smaller ones, we're going to add them. I like to picture these squares in my head when I'm doing this, because it just makes sense for me. And that's what geometry does. It's a lot of visual stuff. I love it. All right, let's go to our notes, take a couple of notes, and then we will practice. And then I'll give you guys the link again. All right. All right, so here we have the Pythagorean theorem. Let's look at this side. What is the length of that side? 3 squares, right? We have 3. So if we squared 3, I want you to visualize a square, because that's what we're doing. So if this side is 3 and we're making a square, what is this side going to be? 3. So now if we want to find whatever's inside, what do we have to do with that 3 and that 3? Do we add them? We multiply them, right? It's a 3 times 3, and that's how we get the 9 squares in here. That's where this number comes from. 3 squared, we get 9. Now let's look at the other square. What is the length of this side? 4. And if we're squaring it, what is the length of this side? 4. And what is the area inside? How many little squares are we going to have? 16. And that's why here we get 4 squared is equal to 16. Now, when we combine them together, we're adding 9 plus 16. And that gives us what? What's 9 plus 16? 25. Those are those 25 squares in here. But when we add them, do we want the number of squares inside, or do we want the length that makes that square so we can find the third side of that triangle? We want this side, right? So what number do we get? If there's 25, what do the sides of the square have to be? They have to be 5. And that's why we look for the square root of it. When we add them, we can't have the square, right? We don't care about the square. We care what makes the square. And that's why we have to do the square root of that total so we know the length of that side. That's the whole purpose of this. And that's where we get this 25. Any questions so far? All right, let's go ahead and start. We're going to look for the missing side of this right triangle. Now notice we have the two smaller sides. But the first thing we have to do is we need to identify what our C is. Our C is always going to be our what? Our longest side, our biggest side. So which one's my biggest side? And we'll call this X. The hypotenuse, which is your X, right? So this is going to be C. And now it really doesn't matter which one we label A or B. I'm just going to say this one is A and this one is B. The text. Do you see it now? We're just finding the missing hypotenuse. Okay. All right, so now using the Pythagorean theorem, because it's a right triangle, we're going to say A squared plus, I don't know, my print's acting like this, plus B squared is equal to C squared. So we have A is equal to 4, and we're going to square the 4. Remember, squaring it means we're creating that square. And now we have B, and B is equal to 8. And what do we have to do to that 8? Square it. And that's going to give us our C, and we call that X. Any questions so far? Okay, make sure you're writing these notes down. So then we have, let's square it. So if we have 4 squared, what do we get when we square 4? We're squaring 4, so we have a square that's 4 by 4. So what's the inside? 16. So this square is 16. How about 8 squared? 64, and that gives us X squared. And what are we going to do to those two sides to get my C squared? We're going to add them, and that gives us, oopsie, that gives us 80. But remember, that's the square. Do we want the square or do we want the square root? We want the square root. So we need to do the square root of 80. And we need to take off that square. So we do the opposite, which is square root. And then whenever we have a radical, we want to go to our calculator. And the first thing we want to do is we want to see if it's a perfect square. So we don't have to waste time in simplifying it if we don't have to. So let's do the square root of 80. Does it give us a whole number or a decimal? Square root of 80. What does it do on the calculator? It gives us a decimal. So now we need to determine, can we simplify it? What's the largest perfect square that 80 is divisible by? $16. And it's 16 times what? Times 5. And what is the square root of 16? 4. And then we multiply it times the square root of 5. So the length of the hypotenuse is 4 square root of 5. So basically it's 4 whole squares and then square root of 5. So that's where your decimal comes in. Any questions? All right, let's try another one. Now let's look at this problem. We first have to identify our C. Which one is our C? Let's call our missing side X. 17. So first identify my C. That's the longest side, 17. And now it doesn't really matter if it's A or B, but I want to keep it consistent. Don't you guys? The side that they're giving us, we're going to call that side A. The side that's missing, I'm going to call it B. Can you switch it around? Yes, but I want to keep it consistent. So the one that we know, A. The one that we don't know will be B. All right, so now we're going to set up our equation. If we have our C, are we going to add the A squared or are we going to subtract it? Think of the water. We're going to subtract it because we have the big square. Now we're going to empty it out into the smaller one, and whatever's left over will be left for the other square. So let's go ahead and set this up. We're going to say C squared minus A squared is going to be equal to B squared. So again, I like to picture it in my head where I get the C and I'm going to square it. So 17 squared, and then minus my A squared. So I'm going to create a square with the A. And you don't have to do this, but if it helps you visualize it, do it. We're going to square the 15, and then we're going to get B squared. So in your calculator, and I'm going to put, yes. Did you have a question? No? Okay. We're going to put 15. Oops, let me delete. Let me share this part too. All right. So this calculator is super cool because we can just put them all at the same time. So if we do 17 squared minus 15 squared, we get 64. So 64 is equal to B squared. But remember, that is A squared. Do we care for the square? Or do we want the square root? We want the square root. So let's do the square root of 64. Put it in your calculator, see if it gives you a whole number. What is the square root of that's giving us the square? So we have to do the square root. So we end up with the square root of 45 to find the length of the side. 45 is divisible by the perfect square of 9 and 5. So it's 9 times 5 is 45. If we do the square root of 9, we get 3, which is this one over here. And then we get the square root of 5. So your answer is 3 square root of 5. Ooh, I like this. It's labeled nicely. We have A is 3, B is 6, and C is the largest side, which is C. Which one's going to be my C? 9. So C is 9. And then I'm just going to label A and B for the other sides. So let's set it up. A squared plus B squared equals C squared. So here's my A, my B, and my C. Let's substitute. We've got 6 squared plus 8 squared equals 9 squared. So let's go to our calculator. I do a lot of like little math mistakes, so I always like to use the calculator just so I don't make those little math mistakes. All right, so let's go to our calculator. We're going to do 6 squared plus 8 squared. And what do we get? 100. And then now let's look at 9 squared.